Okay, today we're going to talk about linear inequalities in one variable. The set of all numbers that satisfies an inequality is called the solution set. To write a solution set, we use one of three ways. One is in a form of set notation, and that looks like the funky set parentheses with x such that, which looks like a vertical line, x is less than or equal to 1, for example. Second way is we can use a number line graph, and that would look like you have the main point of 1 in this case, and it is equal to that 1, so we would want to put a closed bracket at that point, and then this says x is less than or equal to 1, so we're going to write all of the quantities less than or equal to 1 with the big arrow on your number line. The third way is interval notation. And for example, if the number is a solution, boundary point, or endpoint, we use the brackets. Otherwise, if the number is not a solution, we use the parentheses. We'll give you an example in a minute. We have like x is an element in the interval where it goes from negative infinity all the way up to 1, including the 1. So the 1 has that closed bracket because it's a boundary or an endpoint, and then the open bracket because negative infinity goes on forever and there's no boundary to that. That E symbol is a representative that x is an element of the set for the interval given. And that sideways 8 is the infinity symbol. It continues forever, either left or right, left if it's negative. And a linear inequality can be written in the form of ax plus b is less than c. This is in the form of mx plus b, which is a line. That less than can be any less than, greater than, less than or equal to, whatever makes it an inequality. And a, b, and c are in the set of real numbers, where that fancy r represents real numbers, and a can't be 0, otherwise this isn't a line. First property is the additive property of inequalities. We have an inequality with a is less than b. You can add something to both sides and that inequality stays the same. For example, in this set, x plus 3 is greater than or equal to 5. You can add a negative 3 to both sides. That inequality is going to stay greater than or equal to, and 5 minus 3 is 2. If you write that in set notation, x is in the set such that x is greater than or equal to 2. If we write it in a number line process, 2 is our main number. It does include the 2, so we put a closed bracket on it, and it's greater than it, so we're going to shade to the right. And the last way is if we write it in interval notation, x is an element of the interval from 2, including the 2, and bigger all the way to infinity. Second property is the multiplicative property of inequalities. That's where you can take an inequality like a is less than b, and you can multiply something to both sides. If it's positive, that inequality will stay the same. If this c that you multiply to both sides is negative, this inequality flips. For example, if you have the statement 2 is less than 5, and let's just say we multiply both sides by negative 2, then negative 2 times 2 is negative 4, and 5 times negative 2 is negative 10. And this statement, if we just left the inequality where it was, negative 4 is less than negative 10, is a false statement, which is why this inequality needs to flip over if you're multiplying or dividing by a negative, and then it's a true statement. So we're going to solve 2/3 x is less than 10. We're going to multiply both sides by 3 halves in order to get x by itself. On the left side, it all cancels off just to be x. And on the right side, 10 times 3 halves cancels down to 15. And if we write this in interval notation, x is an element of the set from negative infinity all the way up to 15, not including 15, so we put an open parenthesis. In the last example, if we multiply, or if we divide both sides by -5, or that's the same as multiplying both sides by -1/5, the -5 cancels off of the left and you're left with x. Since you're multiplying or dividing by a negative, this inequality sign will be flipping over to a less than or equal to, and 15 divided by -5 is -3. And in set notation, that's x is an element of the set from -infinity all the way up to -3, including the -3, which we use a closed bracket.